Our last speaker is Anna Metke from the University of Central Florida as well, talking about high-fidelity lunar dust simulants. Anna, are you there?
Can you hear me okay?
Yes, yes.
Okay, sounds good.
All right, take it away.
All right, awesome. So first of all, I'd like to say it's great to be here, and it's been really cool to hear about all the amazing work everyone has been doing with our simulants. Just to introduce myself, my name is Anna Metke. I'm the Director of Operations at Exolith Lab here at the University of Central Florida. A little bit of background on me. So my background is a little bit in research, but mostly in organizational and business development. Basically, what that means for me is I get to lead a team of amazing people into battle every day to fight against regolith dust and the Florida heat so that we can bring you guys high-fidelity regolith simulants. And I know just a few moments ago, Parks told you guys a little bit about what we do, and I'm here to tell you a little bit more. Next slide, please. So why do we need high-fidelity analogs? Anything we send into space has to be prepared for the space environment is really what we need to focus on. As we've been developing ISRU hardware and space exploration hardware, we need to test it on Earth to make sure it's ready for the challenges it faces when it's in the intense space environment. Some of the risks we want to address are damages to hardware, electronics, and instrumentation from regolith dust, and we can minimize these risks by testing with regolith simulants. Next slide, please. So here at Exolith Lab, regolith simulants is what we do best. We have a variety of lunar, Martian, and asteroid simulants available for research and educational purposes. And what we focus on is replicating the mineralogy, chemistry, and physical properties of the planetary regoliths. Next slide, please. One of the main physical properties that we focus on replicating is particle size distribution. This is important so that we can mimic the mechanical properties of regolith. We work hard to make sure that our materials are processed appropriately to achieve an accurate size as well as shape. After the materials are processed and the regolith simulants are prepared, we use laser diffraction particle size analysis to verify their size distributions. Next slide, please. So what that actually looks like in real life is we take big rocks and turn them into smaller rocks. So there's a few steps in between. We use a lot of heavy-duty equipment, as well as blood, sweat, and tears of some strong and brave people. We actually use mining equipment to break down the rocks, and then we just use more mining equipment to break them down further. We also sieve out our materials to make sure that they are accurate, or they have accurate and consistent grain sizes. Next slide, please. So once our materials are, or once our minerals, I should say, are all prepared, we combine them in appropriate quantities to get our final products. Next slide. So with all this interest in going back to the moon, I wanted to talk a little bit more about some of our lunar simulants. We have two main lunar simulants available, a lunar Highlands and a lunar Mare simulant. Each one serves as a generic and accurate representation of either the Highlands or Mare regions of the lunar surface. Next slide, please. So due to popular demand and an increase in a lot of dust mitigation research, we've recently made some new simulants available. So what we did is we mechanically process our lunar Highlands and lunar Mare simulants to better simulate the fine lunar dust. Next slide. So we call these simulants our dust simulants. So we have our Lunar Highlands dust simulant, abbreviated as LHS-1D, and our Lunar Mare simulant, or sorry, Lunar Mare dust simulant, abbreviated LMS-1D. And these contain exclusively only dust-sized particles, so we aim for like less than 25 micron particle sizes. Next slide. So I just wanted to give a big special shout out to the amazing people I get to work with every day. They work really, really hard to make sure that these simulants are available for the rest of you guys, and they're literally the best people I know. Next slide. Just a couple more shout outs. Thank you to our science team. Shout out to Dr. Zoe Landsman and Jared Longfox. You guys work really hard to make sure that our simulants are the best they can be. And one more special shout out is to all of you guys out there and all of our clients and partners who make all of our hard work worth it. If you have any questions or want to find out any more information, please feel free to visit our website at exosimulants.com. Thank you.
Thank you, Anna. You really helped us get back on scheduled track as well. So I appreciate all our speakers for being sensitive to my screw up at the beginning. I appreciate that very much. You did have a question, Anna, from Antoine. He asked, is there any plans for simulants that better mimic the absence of flowability of real lunar regolith? And we use your simulants. Many thanks.
Thank you for the question. I'm going to be honest. I think that this is something that we can talk to the science team about. And we make custom simulants as well all the time. So if you have specific needs like you're describing, please feel free to reach out to us and we can work together to make something that's more appropriate for what you're trying to do.
Great answer. Thank you. We use a lot of simulant ourselves, and the lack of large quantities of high fidelity simulant, I think, is one of the most pressing problems the agency has to face in the near term. So thankful to you guys for stepping up and trying to ramp up production of these simulants. With that, we finished the session. I want to thank everyone